Today I'm going to talk firstly about the personalization, the importance of personalization, and give some examples. Then I will talk about some type of recommender systems, some algorithms, and then I will talk about challenges in recommender systems. Why is personalization important for users and for the companies? When we interact with some recommended content, we can discover something that we wouldn't like before, and we can, for us, find some new stuff that we couldn't find if we wouldn't be recommended for that content. Recommender systems are natural for our old days because usually when not thinking about applications, we can just ask for some recommendations from our friends, we can just read some reviews and so on. And from the perspective of companies, it can increase the revenue of the company. And also, it can, a good recommendation system can bring more users to your application, and you can have more customers, and you can sell your content as well. So, I would like to talk about some examples. As Maral already mentioned about Netflix recommendations, I will not talk about some ethical issues. I will just talk about the usage of recommendations at Netflix. So, as you already know, in 2006, there was a content challenge at Netflix, and they gave $1 million to the winner for increasing the metrics of recommender systems. And for Netflix, the business value of recommendations are $1 billion. So when thinking about it, it's a really big value, but actually we don't know the actual value of Netflix, so it somehow is relative. My next example is about TikTok. Many of yours maybe are using TikTok, or maybe not. And why is TikTok so popular? Because they have very good recommender system, and their feed is updating online. So if you watch something and you like that content, they understand that you have interest in that content, and they will update this all. So what is exactly the recommender system or recommender engine? It is some type of information filtering. So, for example, if you have a bunch of contents, you would like something which is personalized. So, recommender system's goal is to find that recommended content and give you that items that you will prefer to use or to watch something else. The general flow or recommender engine is collecting the data, which is the feedbacks of users or the type of content they are using. Then building a model using some techniques like machine learning or other AI solutions. And the first step, and the next step, okay. The next step is to generate recommendations. I'm going to talk about these three steps. So, first of all, about user feedback. When we are interacting with content, we are not necessarily giving some ratings, and it depends on the application. For example, if you're using Netflix, you're watching the movie, you can give thumbs up and thumbs down, and this rating is explicit rating because they know that you liked the content. And when you're just opening the movie, watching it a little bit, and then closing, they don't exactly know why do you close that, and therefore, they cannot give some exact rating to that. So there are two types of feedbacks actually, explicit feedback and implicit feedback. And the difference is that explicit feedback is everywhere. So you can collect many data, but you don't know how reliable this data is. And the explicit feedback is very difficult to collect, but you can rely on that data. And also, there is some noise in two types of feedbacks. So I can give high ratings because I just like that actor, but usually I don't like some types of movies. About recommender models, so there are two main types of recommendation system models. The first type is content-based. For example, if you're a movie lover and you like Wes Anderson's movies, that means that you maybe like colors, and also that means that you will like the Emily. So in content-based recommender systems, we are relying on some features of the items and then recommending it. The next type models are collaborative filtering models, and it relies on the idea that the similar users like the similar content. For example, if user A likes a movie that user B hadn't watched, but they have some mutual movies, then user B most probably would like the movie that user A likes. There are two types actually of the previous model. One is called user-based, and the second one is called item-based. And it relies on similarities of users and items. So here are some examples of user-based recommender systems. First of all, we gain the mean rating of each user. For example, in this slide for user A, the mean rating is 3 plus 3 dividing on 3, so it's 2. Then we are calculating the correlation between users, and this shows the similarity between the users. There are different types of users, and some of them are critics. They can just give lower ratings, and some of them are just fun. They have fun watching movies, and they can give high ratings. So we have to be not subjective and give mean-centered ratings. And after that, we can predict the rating for other items that user would like, and it depends on the similarity with other users, and also the mean value of that rating of other users. The other type of recommender systems are model-based collaborative filtering. It relies on some machine learning techniques, and the main idea is the dimensionality reduction methods. And we use that to split the rating matrix into two parts. The first part is supposed to show the preferences of users, and the second part is supposed to show the item types. For example, here we see the ratings, and we can suppose that movie 1 is about history and movie 2 is about romance. And from the ratings, we can know that user A likes romance and user B likes history. So after multiplying these two matrices, we can gain the predicted ratings and then sort it and give the top K items to user that he would like. Here is the formula, and we are minimizing this function to get the good ratings. And I would like also show some recommendation example at PicsArt. In the first photo, you see the standard flow of seeker recommendations. So actually, they are not personalized. In the second photo, you see the whole content personalized. And in the third photo, you see some part personalized and some part not. So the first user likes Naruto, and therefore we are recommending anime, some stickers. And the third user is gamer, and we are recommending Among Us stickers. And some challenges in recommender systems. So the first one is called start problem. When you're new user and you're using some content, we can get some predictions about yourself. But when you're not interacting with some type of content, we cannot give you something. Therefore, we have a problem, of course, called start users. And this problem can be solved using content-based collaborative filtering, for example. Because we know about information about the content you like, and we can give you some items that are similar to that items. The second problem is sparsity. So usually there are bunch of items in application, but users are interacting with a few of them, and most probably they are very popular items. Therefore, we have that long tail problem as it is shown in this picture. And most probably we will have very popular items in the recommendations. Freshness is about giving a new content to user. For example, when something is in trend, we can just recommend it, but when we are relying on popularity, that new items will need not be fresh, will not be in recommendations, and therefore our recommended items will not have that freshness value. Diversity is, like was shown here, recommending user not only items that he would like, but also some other popular items, for example, or something else that he probably is not aware of, but he would like it. And the last one is scalability. Usually when we're solving some algorithm and we are using any data, we can not sure that when changing the data, that same algorithm will have the same performance on the other data. For example, let's think about a movies data set of Netflix. When we have a high performance on that data set, and we would transform this algorithm to PicsArt data. We didn't have that same performance as they have for that recommendations. It was all. Thank you. If you have any questions.
Thank you very much. Thanks, Lilit. So questions. We have really good time for questions, some 10 minutes. Anyone? Okay. What?
Thanks for the presentation. The question is the recommendation system based on the clustering problems? For example, the one you are using in PicsArt for recommending the stickers, what kind of model? Is it a clustering model that you are using or some kind of a mix? Can you give some details?
Actually, we can use clustering as well, but in this case, we only use matrix factorization. So it depends on the content, and also it depends on the type of recommendations. For example, for stickers, we could use that, but for photos, we may change to other algorithm. Currently, we are using here matrix factorization.
What, sorry? What?
Matrix factorization.
Okay. And what about, is it based on text or the recommendation of stickers, is it based on text?
Do you mean the text of stickers or?
Yeah, you are considering, you are analyzing the kind of names of the stickers?
Okay, I got your question. No, it depends only on interactions. So we can have some contextual information about stickers. We can have, for example, tags, or we have some algorithm that will predict what is on the sticker or on the photo. But we are currently using only the interactions between users and items.
Okay, thank you.
Thank you too.